Good day. Today I'm gonna discuss part of week 6 of quarter 3 in General Physics 1, which is entitled Direct Current Circuit. So we will discuss about parallel circuits. So what is parallel circuits? So parallel circuits are branches to allow current to pass through more than one path, unlike in the series circuit. Parallel circuits basically means that current which passes through in a one path, unlike circuits that they tend to use or they tend to occupy another path for the system to work. So in this diagram, you can see that this is the current and they share the same path. So they flow in a one direction, a circular direction, and this is the resistors. This is resistor 1, this is resistor 2, and resistor 3. And as you can see, there are there are three branches which allow the current to pass through. That is the definition of parallel circuits. As we proceed to the definition of parallel circuit, the voltage between 2 points in the circuit does not depend on the path taken. So whatever the path taken is, the current or the voltage between the voltage of the currents remains the same. Then the individual voltages in a parallel circuit are the same as the total voltage. So whatever the total voltage is, it is the same with the individual voltage in a parallel circuit. So this is the which is tot V total is equal to V sub 1 is equal to V sub 2 is equal to V sub 3, and so on and so forth. However, if we talk about series circuit, the current in each load is not the same as the total current in the circuit. So the current in each load or any section of the diagram, they do not have the same total current. So the total current is the sum of the individual currents across the resistor. So this is the summation. So the sum of the individual current is denoted by big letter I. Total is equivalent to I sub 1 plus I sub 2 plus I sub 3 plus so on and so forth. So in the next definition, the reciprocal of the equivalent resistant in this type of circuit is equal to the sum of the reciprocal of the individual resistance. So the equivalent resistant in a type of circuit is the sum of reciprocal of the individual resistance. So it is denoted by this equation, which is 1 is over R, or R equation is equivalent to 1 over R sub 1 plus 1 R sub 2 plus 1 over R sub 3 plus so on and so forth. This time, we will try some examples to further understand the concept. So in this example, you can see a parallel circuit. So this is an example of parallel circuit with a battery and a resistor and a light bulb. So this is a good example of parallel circuit because the current flows in a one direction from the battery going through the light bulb and passing through the resistors. So the question or the example number 2 ask us to compute the equivalent resistance, current, and voltage of the parallel circuit. So this is the example number 2. So we need to compute the equivalent resistance first. So this is the formula for equivalent resistance. So this is denoted by 1 over R equation is equal to 1 over R1 plus 1 over R2 plus so and so forth. So since we have only two resistors, so we can put 2 ohm here. So this is gonna be 1 over 2 ohms plus 1 over 4 ohms. We will just gonna put the value of R sub 2 with the same value of the resistor 2. The same with the R1 and the resistor 1. So the next step is add these two fractions. So 1 over 2 plus 1 over 4 the same 4 plus 4. So this is 3 over 4 ohms. So in the given example, we need to reciprocate 3 over 4. So we were gonna put 4 over 3 ohms. And the ohm sign will remain in the denominator. We're gonna use our calculator to solve for the exact value. The answer is 1.33 ohms. So this is the step on how to get the equivalent resistance of the circuit. After getting the equivalent resistance, the next thing that we need to do is getting the voltage of both resistor 1 and resistor 2. So this is the step on getting the voltage. In getting the voltage, we need to apply this formula. So I, which denotes the first resistor, so I1 is equivalent to V sub 1 over R sub 1. Since we all know that our resistor has a 15 volt of power, so we will put 15 volts over, so the ohms for the first resistor is 2 ohms, so I'm gonna put 2 ohms there. And then we're just gonna divide it. So the first resistor has a voltage of 7.5 amperes. So we're gonna solve for the second resistor. So we're gonna use the same formula. So V sub 2 over R sub 2 is equivalent to, we have the same voltage, so 15 volts over, so this second resistor consists of 4, is equal to 4 ohms. So we're gonna put 4 ohms, then divide. So the second resistor has a 3.75 amperes. So this is the step on getting the voltage of each resistor in a parallel circuit. And finally, we need to compute for the total current. So the total current is denoted by this formula. I total is equal to total of voltage, which is 15, over the equivalent resistance. So equivalent resistance is R sub EQ. So we're gonna put the values. So the total voltage of the parallel circuit is 15 volts over the equivalent resistance is 1.3, so 1.33 ohms. Then we're just going to divide it. So the answer is 11.27 amperes. So this is the total current of the parallel circuit. Hope you learned something, and that's all.